Hey, algebra students. Here's your review for Chapter 3. Learning Target 1, we start out graphing quadratic functions using the axis of symmetry method. So that means we need to do the negative b over 2a thing to find the axis of symmetry. Even if you have it correctly graphed, yeah, this is still the work that I'm looking for in order to get that. And since you can pretty much just get that one off your graphing calculator, the work is the big part of the credit. Anyhow, so b is 2, so I got negative 2 divided by 2 times negative 1, which is the a value. So negative 2 divided by negative 2 is 1. You can see that makes for my axis of symmetry here at 1. I plug in 1 into my original function to get the y value, which will wind up being my vertex, which helps later on for learning target 3. And so I wind up with negative 1 plus 2. This number right here will always be opposite and double the first term. So, and then I wind up with negative 5. So I've got 1, negative 5 is my vertex. And then at this point, I can either use the y-intercept, which is at negative 6. I can just plot that and the symmetric point over here. Or I could think of this as like the origin and then graph y equals negative x squared, which means I go over 1, down 1, over 1, down 1. And I wind up with my function. All right, looking at learning target 2, graph the quadratic function using the completing the square and then vertex form method. So it's not currently a perfect square, so I'm going to have to move this 1 over to make that happen. I subtract 1 from both sides, and that's how I get this. I do half of b and square it. That's the completing the square part. And that gives me a perfect square trinomial here, which I can turn into x minus 2 squared. Of course, over here, if I added 4, I would have to add 4 to the left, and that's what makes this y plus 3. I subtract that 3 to give me my kind of vertex form here. And of course, when it's in vertex form, you can graph this fairly easily, like we did in the previous chapter. So the vertex moves 2 to the right and 3 down. So that's why you see the vertex here at 2, negative 3. And then my a value is just 1. So I'm graphing y equals 1x squared, or y equals x squared, pretending like that's the origin. Or if I wanted to, I could take a look back at the y-intercept here, which is 1, and graph the corresponding part. So you can see that it all matches up. Learning target 3 utilizes this idea of the vertex in a problem-solving aspect. So Kate owns a cookie stand. He found that his profit is represented by this function right here, and x being the number of cookies sold. So how many cookies does he have to sell in order to earn the most profit? Well, the most profit would be the maximum of this function here. And so how do I find the maximum? Well, that would be the vertex. So it's basically just in a roundabout way asking you to find the vertex. And so I do the negative b over 2a, this being b, this being negative 1 being a. So I get negative 62 over negative 2, which is 31. So this is solving for x. X is cookies. The question asks for cookies. So I'm pretty much done at this point, but I might want a little bit more detail. And so I plug in 31 into my function, and I get 1,038. 1,038, that would be the actual profit when I had 31 cookies sold. So I put that in my therefore statement. If Cade sells 31 cookies, he will maximize his profit, which would be $1,038. Okay, looking on to section number 2. The remainder theorem in synthetic division to find f of negative 2. Well, if you remember, using synthetic division, the remainder is, whatever that is going to be exactly what f of this original number is. And so if I just go ahead and divide by negative 2, the thing that I have here, that would be the same thing as plugging in negative 2 for x in each one of these and then simplifying. So I do the synthetic division. I use the coefficients of each of these terms here. Make sure that if you're skipping an exponent that you put 0 in. I think you see that in the next example. So here we bring down the 1. Negative 2 times 1 is negative 2. And then 5 minus 2 is 3. Negative 2 times 3 is negative 6. 4 minus 6 is negative 2. Negative 2 times negative 2 is positive 4. 2 plus 4 is 6. And so f of negative 2 is equal to 6. I really want you to put your final answer as this. Don't just kind of do the synthetic division and leave it at that. I want you to find f of negative 2, and so use that as your final answer. All right, so here, using synthetic division again, this time to determine whether negative 1 is a 0 to the function. Well, if it's a 0, then that means when I do the synthetic division, the remainder will be 0. And so here, again, you can see I have no x cubed term in the middle, so that's why I have a 0 here. I do the synthetic division all the way through, and I wind up with negative 8 as my remainder. And since my remainder is not 0, it is not a solution. All right, learning target 6, you are now using this stuff to find all the zeros, or in other words, solve or factor large polynomials. So I'm given one of my solutions, 1, x equals 1. And so I put that here, and of course when I do this synthetic division, because it's a solution, I wind up with 0 as a remainder. But the reason why I would do this is because these are the coefficients of my remaining polynomial after I have factored out x minus 1. So I have 2x squared minus 1x minus 6, and I got that from these three things right here. And I'm able to factor this, 2x plus 3 and x minus 2, and use the zero product property to wind up giving me my other solutions in addition to 1, which would be negative 3 halves and positive 2. All right, now this time you are not given 1 to look at, so you got to use the rational roots theorem. So P over Q is all of my possible roots. Not all of them will be, but my rational roots are in there. The P part comes from the factors of my constant, so factors of negative 4, positive, negative 1, 2, and 4. And then the Q comes from the leading coefficient factors, and so that's 1, so just positive, negative 1. I divide those out, and so here are my possibilities for my answers. I have 6 possibilities. Obviously not all of them can be possibilities because I know the maximum number of rational solutions can be 3. Well, I pick from these 6 things to get my first one. I do say that you can use your calculator to find the first roots, speed up the process a little bit, but you still need to show kind of all the rest of the work here. Obviously, use your graphing calculator to confirm that these are the right solutions, but here's the rest of the work that you need to show. You do the synthetic division. I told, well, you can look on the graph and see that 1 is a solution. So I divide by 1, and I wind up with 1x squared plus 5x plus 4. That winds up being pretty easy to factor, and so I use the zero product property to get negative 4 and negative 1 as my other solutions in addition to 1, and that's it. Here's the second half of your review for Chapter 3. Learning Target 8, you are graphing more polynomials, and for Part 8, you got 2 parts. The first part is you're just kind of doing the translation. And so all I'm doing here is I recognize, all right, well, my degree here is 4, so it's going to kind of act like an x squared function, except it's going to be more squared off here at the turning points, and it's going to be steeper here for your end behavior. But otherwise, it's just like a quadratic. It's going to be moved 3 to the right and 1 up. So you can see the vertex is going to be 3 to the right and 1 up. It's negative, so that means it's going to be flipped upside down or reflected. And so all I do here is I have this key point, and then it's like I'm graphing negative x to the 4th, which means 1 squared is 1, so you got, or 1 to the 4th is 1, and then negative, so over 1, down 1, symmetric point over here, but I am going to make sure that it's more squared off here at the edges. If yours looked exactly like a normal parabola, probably didn't give you full credit, maybe give you a 4 or something. So make sure that it's definitely squared off there for this type of problem. For part B, you're looking at graphing a polynomial on your own. And so the key points that you need to have here are the x-intercepts and the y-intercepts. Now the y-intercepts are going to be easy to find because it's the same as before. Just when x equals 0, all of these terms go to 0, and so you get -2. The y-intercept is at -2. But the x-intercepts, well, you're going to have to do that just like you did on the first page. Unless you've been given one, you're going to have to use the rational roots theorem. So I show that work here. Luckily, there's not too many options. You got -2, so 1 and 2 are my only factors. And up here you got 1, so those are my only factors there. So my possibilities for my rational roots are positive, negative, 1 and 2. You can go ahead and use your graphing calculator to find the first root, and 1 is actually one of those roots. So I go ahead and divide by 1 here. Using the synthetic division, I get x squared plus 3x plus 2 as my leftover polynomial, and I am able to factor that, and I get x plus 2, x plus 1, which means my other solutions, or my other x-intercepts, are -2 and -1, in addition to my positive 1 that I found by looking on the calculator. So these are my 3 x-intercepts. I'm going to plot those, and because I know the end behavior of a cubic function, a positive cubic function at that, I know that it's going to essentially go like this. And that's all I'm expecting. If you want to do a couple more points to help you with your end behavior, you could just plug in -3 into here, or probably easier to plug it in here and find that value and maybe get yourself a little bit more assured that you have the right answer. All right, learning target 9, a problem-solving question. So here you're using your graphing calculator to find the line of regression, or the line of best fit for this data, and then use that to predict the population in Urgheil in 2020. It does say use a quartic function, so that's to the 4th power. And so, you know, the steps here, using stat and edit to enter your stuff, and then stat calc to be able to calculate, you know, any of your regression, whichever one I ask you to use, whether it's linear or quadratic or cubic or quartic, whatever I choose here, that's where you'll find it. And then you wind up with a big, long, messy equation. I went ahead and just used the integer. I rounded to the nearest integer. And so when I plugged in 10 into this gargantuan thing, I wound up with y equals 560,000, which you can see doesn't quite fit here. Might make you feel a little bit weird about that, but if you take a look at graphing this and how it fits to your points, well, it would fit your points very well, except that it's, you know, as a quartic, it's going to wind up shooting off to the end here, and you can see that it's going to go pretty high by the time you get to year 10. And so it doesn't surprise me this isn't a very representative answer, and you would have to go ahead and kind of assume that a quartic function didn't represent the scope of the data very well, or at least the trend of the data, even though it matches the dots well. Okay, on to the 4th and final section. Here, graphing rational functions. Again, just like learning target 8, you're going to have one where you're just transitioning first. And so you've got 4 to the right and 3 down. Now this time, it's not a place where it changes direction or a turning point. It's the intersection of your asymptotes that's your key point. So I have a vertical asymptote here and a horizontal asymptote there. And then I just go ahead and graph the stuff without the translation. 3 over x squared. I remember that the 1 over x squared function kind of looked like this guy, but it's stretched a little bit with the 3, and so I just kind of plug in some values, like if x equaled 1, You know, 3 over 1 squared is 3 over 1, which is 3. So if I go over 1 from my key point here, I go up 3, and that's how I get this point here. And of course, it's still symmetric. Just kind of, there it is. So I picked another point here just to give me some assurance that things were going in the right direction, and that's how I wound up with that function. All right, over here, again, this is like the 5 or 7-step process. And so step number 1, find your vertical asymptotes. That's setting your denominator equal to 0 and then solving, so factoring. And I wind up with -5 and +4 as my solutions here. And so those are my vertical asymptotes. So that's why you see vertical asymptotes here at -5 and at +4. The horizontal asymptotes, you've got 3 possibilities. You've got where the numerator, I guess the degree, is bigger in the numerator than it, or smaller in the numerator than it is in the denominator, in which case you're going to just get the x-axis is your horizontal asymptote, which is the case here. They could either be the same, in which case you would just take the leading coefficients, and that would wind up divide those, and that would give you your horizontal asymptote. And if this one, the numerator, were 1 bigger, then you would do the synthetic division, and you'd have an oblique asymptote, and the leftover would be your equation. All right, so anyhow, this time I've got a horizontal asymptote, y equals 0. So that's that. Step number 3 and 4, finding your y and x intercepts. Well, my y-intercept is easy. That's, all the x things go to 0 when x equals 0. And so I get 1 divided by -20, which is -0.05. So when x equals 0, y equals -0.05, and I got that point there, which doesn't help a whole lot. My x-intercepts are, I set the numerator equal to 0, so that's easy, -1. Also, that kind of helps me with the asymptotes. I can kind of guess what's going on here. But I definitely want some more points to figure this out. Now, step number 5 is seeing if it crosses your x or your horizontal asymptote. So I could do that by just setting this whole thing equal to 0 and then solving. And of course, when I do that, I do get an answer. So clearly this one crosses the horizontal asymptote or the x-axis. And I get that here at -1. Let's see, which makes sense since that was my x-intercept. And then I just picked some points to help me graph here. And so, I picked a few in between here to help me out, but it stays pretty flat, so it didn't really help me a lot. But I do have points for -3, -4, +3, and because I've got these asymptotes, I got a pretty good idea of how it's going to work. It just kind of slides along that asymptote. I hit all these points here that I found earlier and then down with that asymptote. And then I picked some other points on the left and right side of these asymptotes. So when I had -6, I wound up with -1/2. So that's down here like that. And I just, again, used my asymptotes to kind of keep me in line. And then when it's +6, I get 7/22. So that gives me another point there. And again, I use my asymptotes to fill in the rest. All right, learning target 11, using direct and inverse variation and all the others to write equations and then solve. So if it says s varies directly as the square of t, well, that means it's k times t squared. If it's just directly, it'd be k times t, but since it's the square of t, I square it. And then it tells me that s equals 729, so I plug that in for s. T equals 9, so I plug that in for t, and then I solve for k. And I get 9. And then I rewrite my equation. S equals 9 times t squared. The final part is it tells me, find s when t equals 8. So now I plug that in, and the rest is pretty easy. 8 squared times 9 is 576, and that's it. So let's see, part B, if x varies inversely, that means it's k divided by v, inversely means divide. And so x equals 6, I plug that in for x, and v equals 5, I plug that in for v, and I'm able to solve for k by multiplying both sides by 5. I get 30. So my equation, x equals 30 divided by v. The final part says find x when v equals 15. Well, just plug in 15 for v and divide, and I get 2. Here is the problem-solving aspect. Learning target 12. So the cost of stainless steel tubing varies jointly, which means I'm multiplying my two independent variables with the length and the diameter of the tubing. So here I got a 5-foot length, 5, and a diameter of 2, so 2. The cost is 48. Now that's where the 48 comes from. I can now very easily solve for k, multiply these, divide by 10, I get 4.8. So I get 4.8 times the length times the diameter. And then it tells me I've got something with 16 and 3, so I plug those in, and I wind up multiplying, I get 230.4. So $230.40 would be the total cost of that pipe. That's it for our review. Good luck on your test.